All right, so one of the big goals in chemistry is that we want to be able to take a look at a molecule. And from looking at this molecule, we want to be able to predict its properties / reactivities. Right, if you look at this molecule, what can you tell me about it? Can you tell me if it's going to react with something? How is it going to react? That kind of thing. So we've completed the first step on that road, which is how to draw these Lewis structures. And with the Lewis structure and some additional tools, we can start answering some questions about their properties. And this is something that we'll be doing throughout the course. So for example, one thing that we can take a look at is that oil and water don't mix. Why? Right? Why do oil and water not mix? Why do some liquids mix with one another and some do not? And if you need a little picture, there's a picture there. The water is down on the bottom and then the oil is on the top, and you can clearly see that the two are not mixing. Even if you stir them up, they would separate over time, right? And the general answer to that is oil is nonpolar, while water is polar. And the general saying in chemistry is that like dissolves like. I like to say like dissolves / mixes like. So if you have two polar things, they will mix or dissolve with one another. If you have two nonpolar things, they will mix and dissolve with one another. But if you have one of each, they will not mix and dissolve with one another. So let's take a look at what polar and nonpolar means. So when we say polar, we kind of mean like a magnet. Right, think about a magnet. It's got a north and a south end, and they attract one another. Same thing with a polar molecule. It has a positive and a negative end. And we can signify that through what's known as a dipole arrow. So it looks like something like this, where this kind of end of this arrow is a little positive sign. That means that we have a partial positive charge. And then over here at the arrow head, that's the partial negative. Another way to symbolize these is these little delta symbols. So you might see delta positive and delta minus, right? That means a partial positive or a partial negative charge. And then if we think about the way two polar molecules or two dipoles would interact with one another, they do it to maximize the electrostatic interaction. So remember that opposites attract when it comes to charge, but when it comes to polar or nonpolar, like dissolves like. So just be careful not to mix those two up, right? But if you had two dipoles, this is about how they would align, the positive with the negative end and vice versa. So we'll call this the electrostatic attraction. And so what that tells us is that polar molecules want to stick to one another. Just how a bunch of magnets would all get stuck together. So what does nonpolar mean? It means that we don't have these charges. And so, for example, if we had a container, and in this container we had some polar compounds, and we just mixed them up, and then we had some nonpolar compounds, over time, we would expect that the polar compounds would want to interact with one another, right, to maximize that positive-negative attraction. So it looks something like this, and then that would exclude the nonpolar compounds. And that's why oil and water don't mix. One is polar, one is nonpolar. All right, so how do we take a look at a molecule and determine whether it's polar or nonpolar? And the polarity of a molecule contributes to many of its properties and reactivities, not just whether it'll mix with other stuff. We'll catch up on this towards the end of the semester when we learn about intermolecular forces and whatnot. So in order for a molecule to be polar, two things must occur. One, they must have a polar bond or multiple polar bonds, depending, how many bonds you have, must have at least one polar bond. So we've already learned about that a little bit. We'll learn some more detail on it, but that's just the difference in electronegativity. And then the second thing is that these polar bonds must face in approximately the same direction. So in order to check criteria number 2, we have to think about the three-dimensional shape of our molecule, which we'll learn about today.